Hello, my name is Muhammad Khalid. Today I will be presenting our project in the embedded, the biomedical sensor that monitors the patient's health and then sends a message through GSM Shield in case of a disturbance or in case to update readings of the patient. We accomplish this by using two sensors, a heart rate pulse sensor and the EEG sensor using an external shield, and to output we use the GSM Shield to send the SMS message. We're presenting with me are Ahmed Drozi Sulaiman, Ahmed Osama and Ahmed Maltawi, and they will explain their individual components. I personally implemented the heart rate pulse sensor. Here is a demonstration of it in action. This is a processing visualization software in order to test the BPM and the IBI, beats per minute, and the interval between pulses. This is my part in the project.
Sensor.
Okay, now how the pulse rate sensor works. As you can see, it fires the LED laser and then captures the movement of the blood in the capillaries. With every pulse, the opacity of the skin, the difference in the opacity of the skin. Therefore, there is a change in the light captured by the light sensor. Hence, we can capture the different beats through the processing software in the Arduino. Okay, that's my part. Now on to the EEG sensor with Ahmed Drozi Sulaiman.
Hello, my name is Ahmed Adel. I worked on the ECG sensor. This sensor is connected to 3 parts in your body, on your 2 hands, like on Khalid here. Two sensors are connected to the hands and 1 to the leg, and the sensor is connected to the shield on the Arduino board. And here we can see the sine waves of his heartbeats, and the code which runs these sensors. It can read a lot of signals from the 3 sensors and use them to transform the waves and to show the waves of the heartbeats. This can be very helpful for doctors to check all of the details of the heartbeats an ECG sensor can show. Now we will go to the GSM transmitter with Ahmed Osama.
This is the GSM Shield. The SIM is put in the drawer at the bottom of it, and the Arduino board is programmed to send the message. We connect the shield over the board. Then we connect the power supply. The power supply should be 9 volts and something about 800 milliamperes. The power button, we press the power button. The network light is blinking. It tells us if the network is connected or not. The light is blinking fast, so it's not yet connected. The light now is blinking at a rate of a rate of one blink per 3 seconds, indicating that it's connected. We will just press the reset button in the Arduino board, and it will send the message. And now Ahmed Maltawi will We'll explain how we put all these components together to come up with the
Okay,
product.
so now that we have everything working alone, we have to put them all together in order for the whole system to work. Now, since we have two sensors and the GSM that sends messages, we have used two different Arduino boards. This is the first one, on which is connected the GSM Shield. Here it is. We have a second one here, second Arduino board, with the shield that connects the ECG sensor here and the pulse sensor, the pulse light sensor here. Okay, so first of all, we need to send data from the Arduino, which has the data of the sensors, to the other one, which does the processing and sends the data using the GSM transmitter here. So what we have tried is to connect both as a master-slave combination, with the one with the sensors as the master sending data to the other one, which is the slave. First, we used the A4 V4 port to the A4 V4 here, but we detected a conflict between the GSM sensor and the processing Arduino down there. So what we used is another alternative, which is the TX-SX combination. Here we have the connection. We connect the TX-SX here to the other, TX-RX here to the TX-RX on the other board, with the TX on the first connected to the RX in the second, and vice versa. Okay, we then begin running the code here, which does one of the following. First of all, the data here detects the BPM from the sensor. Here we can find it. Here we can see that it takes the signal from the sensors and then sends the data to be processed for us to take out the two values of the BPM, which is the beats per minute, and the IBI, which is the interval between the pulses. It then takes those values and sends it over the serial link to the other Arduino board to do the processing. The other Arduino board receives it on its serial link here, which we set up here. It receives the data on its serial link and then reads two integers, which are the BPM and the IBI. After it is done with reading the two values, it checks whether the BPM is below the average rate in which the person is in danger right now, and so it sends a text message saying that the patient is in danger. If the value sent by the BPM sensor is very high, that it reaches 200, we then detect that the device is disconnected from the patient himself, and we send a text message accordingly. Otherwise, we keep it as it is, and sometimes every once in a while, send the readings to his doctor or something. Okay, so I guess that's all, and thank you for watching.